Chapter 8 is on quadrilaterals. We're going to cover 8.1 today. 8.1 is find angle measures in a polygon. That's our objective. We've got some definitions. The first one is diagonal. A diagonal is what I drew on these shapes up here on the board. It's a segment connecting two non-consecutive vertices. Non-consecutive means not next to each other. So if I connected these two vertices, they're consecutive. That's a side. But when I connect these two, they're non-consecutive. As I go around, they're not next to each other. You can put that away. Interior angles. Interior angles are the original angles of a polygon. The original angles of a polygon. Interior angles. Exterior angles. Angles that form linear pairs with the interior angles. So an exterior angle, if I extend this line, okay, that would be an exterior angle. If I extended this side, this would be an exterior angle. But the vertical angle, okay, the angle across from the interior angle, this is the interior angle. The angle across from, that's not an exterior angle. It has to be touching one of the sides of your shape. These two are just the extensions. So you have to be careful what you call an exterior angle. Polygon interior angle theorem says the sum of the measures of the interior angles of a convex polygon is n minus 2 times 180. We just, in our investigation, saw why that's the case. N minus 2 is the number of triangles that can fit in the shape. So it's n minus 2 times 180 determines the sum of the interior angles. There's 6 interior angles in this shape. So it'd be 6 minus 2 times 180 tells you the total of the angles. So quadrilateral has 4 sides, so it's 4 minus 2 times 180. 2 times 180 would be 360. All right? 360 degrees would be the sum of the angles of a quadrilateral. Everybody have it? Gonna move on? All right. Examples. Find the sum of the measures of the interior angles of a convex polygon. All right, so a convex octagon. So what's the formula I'm going to use to find the sum of the interior angles? Seth? N minus 2 times what? Times 180. So I plug in, it's an octagon, so it becomes 8 minus 2 times 180, which is 6 times 180. What is 6 times 180? Yeah. 1080. Is it 1080 or 1000? Yeah, 1080, okay. Okay, number 2, the measure of the interior angles of a convex polygon is 900. Classify the polygon by the number of sides. How can we do this? Now we know the sum of the interior angles. We have to determine the number of sides. How could I do that? How could I determine the number of sides? Eric?
N minus 2 times 180 equals 900.
Yeah. Set it equal to my equation. So we would do n minus 2 times 180 equals 900. And then we simplify, so that'd be 180 times n minus 360, 2 times 180, equals 900. And then we solve for n, so it'd be 180n equals 1260. Right, and then how many times does 180 go into 1260? Yeah, 7. N equals 7. So the shape has 7 sides. What do we call a 7-sided shape? Anybody remember what we call a 7-sided shape? Yeah. Yeah, heptagon. So we have a heptagon. All right, any questions there? No questions. Everybody have this? Okay, moving on. So there's the work. The sum of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by the number of sides. Do that one on your own, and then I'll put the answer up. Do that one on your own. Do 3 and 4 on your own. 3 and 4 on your own. Yeah. It's minus.
Yeah, I realized I accidentally did equals.
Mm-hmm. Yeah, that's right.
It's 10-sided.
What's that?
It's 10-sided and then
Mm-hmm.
whatever that is.
Yeah.
620.
The number 4. Okay, so let's look at these. Number 3 should look like that. N minus 2 times 180 equals 1400. You solve for the n, you get 10. Should have gotten 10 sides. Number 4. The coin shown is the shape of a regular 11-gon. Find the sum of the measures of the interior angles. Okay, so you would plug in 11 minus 2 times 180. You should get 1620 for that one. Questions? Okay. Okay, the measures of 3 of the interior angles of a quadrilateral are 89, 110, and 46. Find the measure of the 4th interior angle. Okay, so what do we know about a quadrilateral? What is some of its measures of its interior angles? Yeah. 360. So how could I solve for that missing side? Yeah.
360 minus those 3 angles.
Equal. Okay, yeah. So we could do, or you could write it, if you want an equation, we could do 360 equals 89 plus 110 plus 46 plus x. Right? And then, as he said, to solve for x, we would subtract those 3 from 360. Jacob, what do you get for x?
115.
What?
115.
115. So, the sum of the measures is 115. Not the sum, the measure of the missing angle is 115. Any questions there? Right has it. Okay. Six, find the value of x shown in the diagram. Is this any different from what we just did? No. 360 minus the 3 angles, what do you get? Somebody on your calculator do it. What do you get for x? Yeah? All right, x equals 72. 7. On number 7, we have 2 missing angles. They are the same. So, how could we do the 5-sided? Okay, it's 5-sided. How could we find that the missing angle is S and T? Let's write an equation. How could I write an equation to find the missing angles S and T? What's the first thing I have to do before I find the S and T? What would I have to do? Well, we need to know the sum of the angles, right? So I would do my 5 minus 2 times 180. That gives me the total. That's going to equal to 93 plus 156 plus 85 plus what? Remember, we're finding S and T. What could we make S and T?
2x.
Yeah, each one of those is x. They're the same, so we'll call them both x, so that's 2x. So plus 2x. All right, so then solve that, so that's going to be 540 is 5 minus 2 times 180 minus, what's 93, 156, and 85? Add those up. 540 minus what? What do you get, Gunner?
334.
540 minus 344 equals 2x. So then we have to solve. So that's going to be, what, 196? 2x equals 196. We'll finish it up here at the top. 2x equals 196. So x equals to what? Divide by 2. All right, thanks. So x equals 98, right? If we finish the problem. Any questions on that? X equals 98. Everybody has it. Okay, we did our math wrong. It was 206. I said 196. It was 206. So you need to correct that. 540 minus those three angles is 206. 206 divided by 2 is 103 is what we should have gotten. 103. Any questions? All right. Exterior angles. So we draw five lines here, as in step 1. At each vertex, we shade one exterior angle. So as we're going around, spokes on a wheel, right? We're shading one exterior angle. So I'm going to mark these exterior angles like this. Right? We shade those. Anybody have an idea what the extra angles would add up to if we shaded them, if we put them all together? Any ideas? Okay, if we measured these with our protractor and added them up, they would sum to 360. All right. The extra angles going one way, okay? So we're not counting, you know, the ones we shaded were all the same direction, with the lines the same direction. So we're not counting if I extended this line this way. We're not counting that, okay? We're not counting both sides. We're just doing one extra angle per vertex. If we put those together, they will always, no matter how many sides the shape has, the number of sides doesn't matter. It could have 20 sides. The extra angles, as you go around clockwise in this case, or you could go counterclockwise and count the other ones, but as you go around this, they will always add to 360 extra angles. So the polygon exterior angle theorem is the sum of the measures of the extra angles of a convex polygon, one angle at each vertex, is 360. Taylor and Duncan and Brandon, you can watch the video on the notes of the notes. We're about done. You can watch the video on Canvas to see what we went over today. So the extra angle theorem, again, the extra angles sum to 360. So if we had to find the value of x below in the diagram, how would we do it? How would we solve for x? What would my equation be? Eric.
3x plus 89 plus 67 equals 360.
Right. Or we can break it down and we add each of the angles. So it would be x plus 2x plus 89 plus 67 equals 360. Solve for x, so 3x plus 89 and 67 was 156 equals 360. So we subtract 156 from 360. $204. 3x equals 204. So x equals $68. X equals 68. Answer is B. Questions? Okay, so here we have a convex hexagon. Has an exterior angles of 34, 49, 58, 67, 75. What is the measure of the sixth vertex? How would we find the sixth vertex? What would I do? Carly, how would I find the sixth vertex? Nope, you don't have to do that's the interior angles. We're not doing interior angles, we're doing the extra angles. There's no equation for the extra angles. We know the sum of the extra angles is always what? 360. So what if I know 5 of them, I got to find one. What do I do, Kayla? Okay, yeah, if you did an equation, or you can do it this way: 360 minus those 5, right? Minus 34, minus 49, minus 58, minus 67, minus 75. All right. We subtract all those. And that's going to give me my sixth vertex. Go ahead and calculate that. What is it?
85.
What?
85.
85. So 85 is the missing angle. All right, any questions? No questions. Okay. Oh, should have been 77. Calculation error there. Should be 77. regular polygons. So we have this trampoline shown, shape of a regular dodecagon. Find the measures of each interior angle. Find the measures of each exterior angle. All right. It's regular. So what does that tell us about all the sides and all the angles? They're all what? The same. So we can find the total of the angles of the shape, right? We take our n minus 2 times 180. We have to add one more step. Okay? We can find the total of the angles. We know all the angles are the same. What would I do to that equation to figure out one of the angles? If it's a dodecagon. How many sides is a dodecagon? 12. So what would I do? We have to go one step further to find one angle. We can find, yeah. Right, we divide n minus 2 times 180 by 12. Okay, so for A, we would have n minus 2 times 180 divided by, we'll say n because we haven't plugged in 12 yet. Then you plug in 12, so it's 12 minus 2 times 180 divided by 12. So that's going to be 10 times 180, which is 1800 divided by 12. So I think it should be 150. Yeah. So the answer is 150. All right. Each angle is 150. So that takes care of the interior angles. The exterior angles. Okay, how can I find the measure of each exterior angle? We know the total of the exterior angles adds up to what? 360. There's 12 sides. So what do I do to 360 to figure out one?
Divide by 12.
Divide by 12, right. So for B, we take 360 divided by 12. And that's going to be 30. Each exterior angle is 30. Any questions?